Hello everyone, we're going to be going over section 8.3, which is on the law of cosines. So in our last section we went over the law of sines, now we have the law of cosines. So we have three objectives. One, we want to solve an SAS triangle. Two, solve the SSS triangles. And three, we want to solve applied problems. So our SAS triangles, these are going to be when we know two sides and one angle. And for number two, solving SSS triangles, that's going to be when you know three sides and no angles. So in our last section, we used the law of sines to solve for case one, which were side angle angle or angle side angle triangles, and case two, which were side side angle of an oblique triangle. So in this section, now we're solving cases 3 and 4 with using the law of cosines. So case 3 is going to be two sides and the included angle are known, and case 4 is that three sides are known. Then for our theorem, for our law of cosines, we see that for a triangle with sides A, B, and C, and opposite angles, capital A, capital B, and capital C, respectively, are going to give us these three formulas. Formula 1, or equation 1, b and c squared is equal to a squared plus b squared minus 2 times ab times cosine of capital C. Then we have b squared is equal to a squared plus c squared minus 2 times a times c times cosine of capital B. Then we have a squared is equal to b squared plus c squared minus 2 times b times c times cosine of capital A. So we see our capital letters, these are our angles, our lowercase letters are our sides. So we have our three different equations here that allow us to solve for different things. Each one of these formulas or equations can also just be stated in words. So if you want to remember that better in words, maybe you can think of it as the square of one side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. So if we look back here, we see that our lowercase c corresponds to uppercase c, lowercase b corresponds to uppercase b, lowercase a corresponds to uppercase a. So those are those differences in solving for the angles. And then we just have the squares or the sum of squares of the other two sides minus twice the product of those other two sides times the corresponding angle. So the Pythagorean theorem is actually a special case of the law of cosine since we use equation 1 with a right triangle. Since we use equation 1 with a right triangle or 90 degrees, this would end up giving us the cosine of 1, and so, cosine of 0, so then we would end up with just c squared is equal to a squared plus b squared. And so that's how we end up getting our Pythagorean theorem. It's just the law of cosines using equation 1 with a right angle. Just a fun fact. So all right, objective 1, we want to solve SAS triangles or side angle side triangles. The law of cosines is used to solve for case 3, which applies to triangles that have two sides and one known angle. Example 1, not 2. We want to solve the triangle for A equals 2, B equals 3, and capital C is equal to 60 degrees. So this is a capital C, this is not a lowercase c. Try to write them much bigger so it's very different and very obvious that these are different values. But we see here in our picture, we have our triangle, our one known angle here, which is 60 degrees. We have our two side lengths, 2 and 3, and what we're looking for are our angles B and A, and then our side length C. So first things first, we want to solve this triangle. We know we're trying to solve for all the sides and all the angles. So the first thing we can do is we can pretty easily find the value of the side C. And we can solve for the side length C using our equation for the law of cosines. So we can say we can solve for side C using, and in this case it's going to be equation 1 of our law of cosines. So using law of cosines, we get that c squared is equal to a squared plus b squared minus 2ab times cosine of uppercase C. So let's write that out again here. So we're going to get c squared is equal to a squared, which is going to be 2 squared, plus b squared, which is going to be 3 squared, minus 2 times 3 times cosine of 60 degrees. So we can do our best to simplify these values. So 2 squared is just going to be 4 plus 3 squared, which is 9, minus 2 times 2 is 4 times 3 is 12, times cosine of 60 degrees, which we can use our unit circle on that, or any other way that you would want like to calculate cosine of 60 degrees. It's just going to be 1/2. So simplifying further, we get c squared is equal to 4 plus 9 minus 12 times 1/2. 4 plus 9 is going to end up giving us 13 minus 12 times 1/2, which is 6. So this gives us that c squared is equal to 7, which means that c is equal to the square root of 7. So all right, we found our last side length c. So now we want to find our angles A and B. We'll highlight this here in blue. It is one of our answers, but it's not technically our final written answer. So now we want to find angles capital A and capital B, which we can now, since we found side C, or the length of side C, which is the square root of 7. So starting with A, we can say that we can use equation 2 to solve for B, because that is the equation that has the angle B, to solve for angle B, and equation 3 to solve for A. Because that's the equation that corresponds to our angle A, or it includes our angle A. So let's just start for A. So for A, we're going to use equation 3, which tells us that A squared is equal to B squared plus C squared minus 2BC times cosine of capital A. So plugging in our values, A was 2, B was 3, so we have 2 squared. 2 squared is equal to 3 squared plus the square root of 7 squared, so that's just going to be 7, minus 2 times 3 times the square root of 7 times cosine of A. So A is our only missing term, so we're going to end up needing to solve for A. Let's just simplify. So 2 squared is going to be 4, 3 squared is 9, plus square root of 7 squared, which is going to be 7, minus 2 times 3 times the square root of 7. This gives us 6 times the square root of 7 times cosine of A. So simplifying further, 9 plus 7 is going to be 16, minus 6 times the square root of 7 times cosine of A. Simplifying further, we subtract 16 from both sides. We get negative 12 is equal to negative 6 times the square root of 7 times cosine of A, which now if we went and solved for cosine of A, then that means that we're dividing negative 12 by negative 6 over square root of 7, or 6 times square root of 7. So this gives us negative 12 over negative 6 times the square root of 7. But we see that negative 6 and negative 12 have the common factor of negative 6. So if we end up canceling out our negative 6, this leaves us with 1, and this leaves us with 2. So this is really equal to 2 times the square root of 7. Now from here, if you're using a calculator, you could easily just leave this as 2 times the square root of 7. But remember, if you do want to rewrite it, this is also equal to 2 times the square root of 7 over 7. You can use either one of these values. They are equal. So now if we want to solve for a, this means that a is going to be equal to the inverse cosine of, and I'm just going to use 2 over the square root of 7. So finally, now we have this value. We definitely want to use that calculator to go ahead and calculate this value. And if you do, it should come out to about 40.9 degrees. So we found a value for A. We're saying that A is about 40.9 degrees. Now we want to find the value for B. So we'll say for B, we want to do the same thing. So we want to use our equation 2 for B. And equation 2, remember, was B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. So for B, we get B squared is equal to A squared plus C squared minus 2 times AC times cosine of angle B. So once again, plugging these values in, B is 3, so we get 3 squared is equal to A squared, which is 2 squared, plus C squared, which was the square root of 7 squared, minus 2 times A, so 2 times 2 times the square root of 7, times cosine B. And from here, we'll just simplify. So 3 squared is 9, 2 squared is 4, square root of 7 squared is going to be 7, minus 2 times 2, which is 4, times the square root of 7 times cosine of B. 4 plus 7 is going to give us 11. And then we can go ahead and subtract 11 from both sides to get negative 2 is equal to negative 4 times the square root of 7 times cosine of B. Or now, if we go ahead and we solve for cosine of B, we'll end up getting negative 2 divided by negative 4 times the square root of 7, where negative 2 and negative 4 both have common factors of negative 2. So this just becomes 1, and this then would become 2. So simplifying this, we can end up getting 1 over 2 times the square root of 7. So, all right here. So once again, you can rewrite this so you don't have a square root on the bottom, but since we are just plugging into a calculator, it's not the biggest deal in the world. So let's go ahead and take an inverse cosine of both sides. And this leaves us with B is going to be equal to cosine inverse of 1 over 2 times the square root of 7, which when we go ahead and plug this into a calculator, this is going to give us 79.1 degrees. So now we found the things that we're missing. We found our side length C, and we found our angles A and B. Now we just want to go ahead and check, make sure that our angles add up right. We can say thus, since A plus B plus C is equal to 180, we can rewrite A, B, and C. So we know that A was 40.9 degrees, B was 79.1 degrees, and C was 60 degrees. Remember, we were given that in our problem. And adding all these values up, we do end up getting 180 degrees. So we know that our angle measurements are correct, and we know that our value of C was correct. So, and I'll write our final answers. Little c was equal to the square root of 7. A is equal to 40.9 degrees. And B is equal to 79.1 degrees. So, all right, those were our values. That's how we went about solving for our SAS triangle. Now, it's important to make a note. Something that we did in this problem when we solved for our angles A and C, what we did is that we used the law of cosines again. We could have used the law of sines, but what happens is that if you want to use the law of sines when you have two sides that are known and one angle that are known, when you solve for your other angles, you will end up getting multiple solutions for those angles. As we saw in one of those problems that we had from our last section, that this does happen in the case where we know two sides and one angle of your triangles. So in cases like these, since we already know the law of cosines, it's much easier to use the law of cosines and just end up with one definite solution than finding two and having to check which one is going to be the correct solution. So that's why we use the law of cosine in this problem instead of using the law of sines, even though you can use either one. So let's make a note of this. So you can use the law of sines or the law of cosines when solving for angles A and B. But we prefer using the law of cosines since we will, or since our results will be one solution as opposed to two solutions if we use the law of sines. So just a note that you can use both. Just using the law of cosines is going to end up being easier since you don't have to do any of that checking to see which one is going to be correct and which one is going to be incorrect. You will just get the one final solution when using the law of cosines. So let's zoom out real quick. Quite the long problem there. All right.